start this session with the Millen's quotes. You are braver than you are believer, and stronger than you seem, and smarter than you think. Good afternoon to one and all present here. We are in the second session of Day 1 International Webinar on Recent Trends in Pure and Applied Mathematics. I invite Mrs. S. Kalachelvi for giving introductory address.
Assistant Professor, PG Department of Mathematics, Government Arts College, Vellore, Madurai. He has more than 21 institutions at various positions. He has published 61 papers. He has attended more than 72 national and international conferences, seminars and workshops. He has organized 4 seminars and 5 conferences at the national level funded by UCC in NPHM and Danzig. He has produced 15 PhD scholars and 35 MPhil scholars. Presently, 3 part-time PhD scholars is working under his guidance. Additionally, he has completed 1 major research project funded by DST, and also he completed 1 minor research project funded by UGC. With this brief introduction, I would like to welcome our resource person, Dr. S. Balamurugan, for the discussion about various domination parameters. Welcome you, sir.
Thank you for nice introduction about me. I would like to thank the organizers, Dr. Anida, for nice opportunity to me. It's my title of session is discussion about various domination parameters. So this is my outline of the presentation: domination, strong domination, weak domination, connected domination, disconnected domination, total domination, and coloring, and chromatic strong domination, then chromatic weak domination, then chromatic connected domination, and chromatic total domination. Finally, we discuss about degree divisor graph. So these are the my main area of my research. So what is a dominating set? A subset D of V is a dominating set of G if every vertex இப்போ கரெக்டா கேட்கலாம் இப்போ கரெக்டா கேட்கலாம்
சார் கேக்குது some echo creates சார்
ஓகே 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 So this is what is a dominating set? A subset D of V is said to be a dominating set of G if every V in V minus D there exists U in D such that U and V are adjacent, then it is called dominating set. It is easily example that every person in outside is adjacent to some person in the inside. Every person in outside is adjacent to some person in the inside. So that is called a dominating set. And the minimum cardinality of a dominating set, it is called domination number. And also, a dominating set is D of G is said to be a minimal dominating set. If a vertex removed from D, then again it is not a dominating set for any U in D. So it is called the minimal dominating set of G. For example, you take one V4, you take one V1, V2, V3, V4, a point on path. Dominating set means.
Sorry, your voice is not clear.
Not clear? Okay. So now it's clear? Okay. For example, you take a P4. V1, V2, V3, V4. Right? So now V2 is adjacent to V1 and V3. So V2 and V3 is a dominating set of P4. So you take a one vertex set V of G, can be partitioned into 2 sets. One is you needed set, is a dominating set. So every V in V minus D, there exists U in D such that U and V are adjacent, then it is called a dominating set. So this is the definition of the dominating set. And what is a weak dominating set? A subset D of V is said to be weak dominating set of G. If every vertex V in V minus D, there is adjacent to some vertex U in B, such that and such that U and V are adjacent and degree of U less than or equal to degree of V. Degree of U less than or equal to degree of V. It is called a strong dominating set. The minimum cardinality of a strong dominating set is called a strong domination number of G. Right? So what is the minimal? So what is the minimal strong dominating set? A strong dominating set D of V is to be minimal strong dominating set if D minus singleton U. Allow this, you take a dominating set, whenever you single point remove from D, then D minus U is not a strong dominating set. So that type of set it is called a minimal strong dominating set. Right? Okay. You take one graph, suppose you take K1 comma N, you take a star graph, suppose one point U, the remaining points are U1, U2, U3, etc., UN minus 1. So the fully vertex of U is a strong domination number. U is so only one point of star graph, right? So star graph of the strong domination number is only one. So this is the exactly definition of the strong dominating set. So you take one vertex set. The same thing dominating set. We add one more condition. We add one more condition. The condition is degree of U greater than or equal to degree of U. So strong point. அதாவது ஸ்ட்ராங் பாயிண்ட் அதாவது அந்த பாயிண்டோட டிகிரி வந்து அதிகமாக இருந்தால் தான் அந்த செட்டை வந்து கம்மி பண்ணுவோம். ஸோ அப்போ டிகிரி ஆஃப் பி டிகிரி ஆஃப் பி. ஸோ திஸ் ஒன்லி கண்டிஷன் ஆட் இதில் டாமினேட்டிங் செட்டோட வி ஆட் ஒன்லி ஒன் கண்டிஷன் ஆஃப்டர் டாமினேட்டிங் செட், ரைட்? இட் இஸ் டிகிரி ஆஃப் யூ டிகிரி ஆஃப் பி. So this is the weak dominating set. So I think strong dominating set introduced by strong and weak dominating set both are introduced by 1966. 1996 I think. 1996. Dr. E. Sambat Kumar and L. Puspalada was introduced by this concept. So this is the very nice concept of the dominating set, right? So here it is. We discuss about weak dominating set. Weak dominating set means a subset D of V is said to be weak dominating set of G if every vertex V in V minus D there exists some point in U in D such that U and V are adjacent and degree of U less than or equal to degree of V. So strong dominating mean degree of U greater than or equal to degree of V. Weak dominating set mean degree of U less than or equal to degree of V. So this is the weak dominating set and the minimal cardinality of weak set is called a weak domination number of G and it is denoted by comma W of G, right? Again we discuss minimal weak dominating set. Whenever you have to find any parameter, then immediately we can find a minimal condition of that parameter. So what is a minimal weak dominating set? So, a weak dominating set D of V of G is said to be minimal weak dominating set. If D minus singleton U ஒரு செட்ல இருந்து ஒரு பாயிண்ட் ரிமூவ் பண்ணும்போது again அது not a weak dominating set. That set not a weak dominating set. It is called a minimal weak dominating set, right? Okay. So now I'm going to. So this is the main definition of the weak dominating set. So already we know the dominating set. So what are the weak dominating? What are the strong domination? So we put only in additional condition of two things. Degree of U greater than or equal to degree of V, that is called the strong domination. Degree of U less than or equal to degree of V, that is called the weak domination, right? So it is a connected dominating set. Connected dominating set is also defined by Dr. E. Sambat Kumar, I think. So a subset D of V is said to be connected dominating set of G. If D is a dominating set and induced D is connected subgraph of G. So you take one subset from G. You take one subset from G. That set of induced subgraph is a disconnected mean. It is called it is a connected mean. It is called a connected dominating set. Right. So this is a definition introduced by Dr. E. Sampath Kumar, I think. So here it is. What is a minimal connected dominating set? The same thing idea. Whenever you take one minimal dominating set, then one single point remove from that set. A single point remove from that set. Then D minus U is not a connected dominating set. So that type of set is called a minimal connected dominating set. Right? So the minimal cardinality of a connected dominating set, it is called a connected domination number of G and is denoted by comma C of G. Right? Right. So this is called a disconnected dominating set. Disconnected dominating set mean this concept introduced by myself and Dr. G. Prabhakaran. I think 2010 this concept was introduced by myself and Dr. G. Prabhakaran. A subset D of V is said to be disconnected dominating set of G if D is a dominating set and the induced D has disconnected. Induced D has disconnected. So, எப்படி induced D வந்து connected நம்ம சொல்றோமோ at the same time induced D has disconnected mean, so that is a disconnected dominating set. And what is the minimal disconnected dominating set? Already we know the idea into minimal disconnected dominating set. A set D is said to be a minimal disconnected dominating set if D minus singleton U is not a disconnected dominating set. Right? So the minimal cardinality of a disconnected dominating set is called a disconnected domination number, and it is denoted by comma DC of G. It is gamma DC of G, right? Okay. At the same time, the disconnected dominating set in Kn, suppose you take in Kn, no vertex subset in is disconnected. I think it's correct. Okay. In Kn, no vertex subset is disconnected. Is right? So therefore, it is a disconnected dominating set that does not exist in complete graph. Right? So அப்போ வந்து நீங்க complete graphல வந்து disconnected dominating set நம்ம பேச முடியாது. So therefore, it is a remark of that idea. Right? In Kn, no vertex subset is disconnected. Therefore, a disconnected dominating set that does not exist in complete graph. So hence we consider only non-complete graph. So you take any graph, but the graph is only non-complete. அந்த graph எல்லாமே வந்து non-complete இருந்தா தான் நம்ம என்ன செய்ய முடியும். So we can find the disconnected domination number, right? So disconnected dominating set we have only one paper. Till now, இதுல வந்து இப்போ ஒரே ஒரு பேப்பர் தான் நம்ம பப்ளிஷ் பண்ணிருக்கோம். So it is I think for all the complete, we have characterized all the complete graphs of G, right? All the standard graphs, I think complete bipartite graph and cycle and path, star graph and double star graph. So again we compare the parameter. So comma DC means disconnected dominating set. So comma DC is lies in comma and independent number of G. So comma always comma DC வந்து எதுக்கு இடையில இருக்குன்னு நம்ம சொல்லிருக்கோம். Comma DC is lies in comma and alpha naught of G. Alpha naught of G means independent number of G. So that is only one point. Another one, so for any graph G, comma DC of G equal to N if and only if G is equal to Kn bar. So totally you take a totally disconnected graph, then comma DC of G always N. Right? So another one result, given any integer K greater equal to 0, there exists a graph G such that comma DC of G minus comma of G equal to K. So this result is easily, we can find this parameter. And another one theorem is very standard theorem, I think. for any two integers a comma b with 2 less than or equal to a less than or equal to b, there exists a graph G such that commodity of G equal to a and alpha naught of G equal to b. So this is the main theorem of this paper. So we have derived only 6 or 8 theorems. So remaining many more அளவு இதுக்கு அப்புறம் நிறைய இருக்குது. So those are interested students doing in this area. I think disconnected dominating set of some graphs, right? So okay. So now yeah, total dominating set. Total dominating set means a dominating set D is a total dominating set if the induced subgraph D has no isolate. நீங்க எப்படி induced D has disconnected, induced D has connected அப்படி பேசுறீங்களோ, the same idea induced D has no isolate. So that type of graph is that type of definition is total dominating set. Total dominating set. The minimum cardinality of a total dominating set is called a total domination number of G, right? Okay, we consider one graph, right? A star with one pendant, right? Sorry, triangle with one pendant. You take 1,3 and 3,4 because one dominate பண்றதுக்கு அந்த third point வேணும், third dominate பண்றதுக்கு அந்த single point 1. So automatically 1,3. So then 3,4 and 2,3. So here 3 total dominating sets are there. So we got, therefore total domination number is only 2. The cardinality of D1, T2, T3 is equal to another is a 2, right? So this is a total dominating set of G, right? Suppose okay, it's a coloring. So now we have discussed dominate. What is a dominating set? What is a strong dominating set? What is a weak dominating set? What is a connected dominating set? What is a disconnected dominating set? And total dominating set, right? So many more parameters we have to discuss. Here, totally disconnected dominating set is a new domination parameter. That parameter discussed with Dr. G. Prabhakaran recently, I think 2010. So only paper was published in this area. So those are interested people. We continue the research of totally disconnected graph, disconnected dominating set, disconnected area, right? We compare with the connected dominating set as well as disconnected dominating set. Right? So it is one main area of huge research, right? Now I will start coloring. What is a coloring, right? Coloring that everybody knows, right? So suppose 2 vertices are adjacent, we will give different colors. No 2 vertices are adjacent, we will give same color. So the minimum number of colors as in the graph, it is a chromatic number. The minimum number of colors as in the graph, it is a chromatic number, right? So now yeah, I will start a chromatic strong dominating set. So I mingled with the domination parameter with the chromatic number. So already discussed with many more domination parameter. Now what is a coloring? After that, we mixed with the domination and the coloring parameter, right? So that is called we can get a new parameter of this area, right? So it is a chromatic strong dominating set. In previously DOM chromatic set, Dr. Bhubala Ranjini and T.N. Janagiraman was introduced to this concept DOM chromatic set. A set D is said to be a DOM chromatic set if D is a dominating set and into chi of induced D equal to chi of G. D is a dominating set and chi of induced D equal to chi of G. அதாவது ஒரிஜினல் கிராஃபோட கலரிங்கும் நீங்க எடுக்கக்கூடிய சப்செட்டோட இன்டூஸ்ட் கிராஃபோட கலரிங்கும் சேமா இருக்கும். அப்படி இருந்துச்சுன்னா அந்த நீங்க எடுக்கிற சப்செட் என்னவா இருக்கணும்? இட் இஸ் அ டாமினேட்டிங் செட். ஸோ அந்த இண்டூஸ்ட் சப்கிராஃப் உடைய கலரிங் as well as original graph coloring both are same, then it is called a new parameter. It is a DOM chromatic set. So that concept introduced by D.N. Janagiraman and Pubala Ranjani, I think 2006. After that, myself and my guide extend that idea, chromatic strong dominating set. Chromatic strong dominating set. A subset D of V is said to be a chromatic strong dominating set of G. If D is a strong dominating set and chi of induced D equal to chi of G. Chi of induced D equal to chi of G. The minimum cardinality of a chromatic strong dominating set in a graph G, it is called a chromatic strong domination number of G, and it is denoted by comma SC of G, comma SC of G. So this is the chromatic strong dominating set. அதுக்கு முன்னாடி நீங்க என்ன பார்த்துக்கணும்னா டாம் chromatic set. டாம் chromatic set ஓட உங்களுக்கு நான் டெஃபினிஷன் ஆல்ரெடி நான் உங்களுக்கு ஃபுல்லா கொடுத்தாச்சு. அதாவது a subset D of V is said to be a டாம் chromatic set of G if D is a dominating set and chi of induced D equal to chi of G. So டாம் chromatic set introduced by D.N. Janagiraman and Pubala Ranjani, right? The chromatic strong dominating set introduced by myself and my Gurunatha Dr. V. Swaminathan, right? Okay. So this is the example. It's a chromatic strong dominating set. 1 minute. You take D1 is equal to 1. 1 is, I think the graph of coloring is here 3, right? Up here you take 1, 5, 2, LR 3, 4, 5. 1, 2, 5, R 3, 4, 5. Here it is 2 chromatic strong dominating sets are there because the cycle with 3 vertex of G is always, the coloring of that graph is always 3. So therefore மேல ஒரு சைக்கிள் இருக்கு, அதுக்கு அந்த செட் எடுத்தாலுமே அதுலயும் உங்களுக்கு என்ன வந்துரும்? So chromatic strong dominating set வந்துரும். So another one D2 3, 4, 5 is also a chromatic strong dominating set. So therefore இந்த D1 இன்டியூஸ் பண்ணி பாத்தீங்கன்னா ஒரு சைக்கிள் கிடைக்கும். அதாவது 1, 2, 5 போட்டீங்கன்னா பிகாஸ் 1, 2 நீங்க இன்டியூஸ் பண்ணீங்கன்னா 1, 2 ஒரு லைன் வரும். 1, 5 இன்டியூஸ் பண்ணீங்கன்னா 1, 5 ஒரு லைன் கிடைக்கும். 2, 5 இன்டியூஸ் பண்ணீங்கன்னா 2, 5 ஒரு லைன் கிடைக்கும். ஸோ அப்போ we get one cycle. அப்போ சைக்கிள் ஆஃப் அது அப்போ D1 ஓட இன்டியூஸ் கிராஃப் வந்து ஒரு சைக்கிள் கிடைக்கும். The induced graph of D1 is one cycle and induced graph of D2 is also one cycle with a 3 vertex. So the original graph of coloring always 3, the induced graph of D1 is also 3. So we want only that okay. So therefore here it is D1 equal to 1, 2, 5 and T2 is equal to 3, 4, 5. So therefore the chromatic strong dominating set, the domination number is 3. So chromatic strong domination number is 3 always, right? And yeah, here it is a chromatic weak dominating set. Chromatic weak dominating set. What is a chromatic weak dominating set? So I think after my research, we extend that idea, chromatic weak dominating set. I think myself and one scholar now she get a doctorate degree. So both are extend that idea, a chromatic weak dominating set. So this concept introduced by myself and my scholar. Okay. So a subset D of V is said to be chromatic weak dominating set of G. If D is a weak dominating set and chi of induced D equal to chi of G. Chi of induced D equal to chi of G. So the minimum cardinality of a chromatic weak dominating set in a graph G, it is called a chromatic weak domination number of G and is denoted by comma WC of G, comma WC of G. So what is a chromatic weak minimal dominating set. What is a chromatic weak minimal dominating set? A set D is said to be chromatic weak minimal dominating set if D minus singleton U is not a chromatic weak dominating set. So there is this idea, chromatic weak dominating set, right? Okay. So this is the example of a chromatic weak dominating set. So chromatic weak dominating set, right? So you take one star graph. So here this and the star, Untitled that graph of coloring, chi of that graph is equal to 2. Any fiber graph, then chi of g equal to 2. So therefore, this graph is for fiber rate, automatically the coloring of this equal to 2. So you take let it is equal to A, then B, then C, and D and E. Because the pendant vertices of A, C, D, E of induced subgraph is also pendant, right? Then we need one more vertex. So therefore you take a B from that graph. So automatically you take full vertices of G, because the original graph of original graph of the coloring number is 2. So therefore the induced D of G is also the coloring of induced D is equal to 2. So therefore comma WC of G is equal to whole vertices, that is mean 5, right? So now chromatic weak. Okay. Now what are the pending results in this area? What are the pending results in this area, right? Now DAM chromatic set introduced by Dr. Bhubal Ranjani and T. N. Janagiraman. Chromatic strong dominating set introduced by myself and my Gurunatha, Dr. V. Swaminathan. And chromatic weak dominating set introduced by myself and my scholar. No. Okay. So all the people are get a doctorate degree from that area. Now, pending. What are the pending results? So I think we can find a full set of the DAM chromatic set, because DAM chromatic set Bhubala Ranjani and Janagiraman introduced only few area, only a few theorems. I think only one thesis. There I wrote it, right? Now, what is a full set? Full set mean DAM. What is a DAM full set? What is a chromatic strong DAM full set? What is a chromatic weak DAM full set? Then we have to the result that is a full set mean DAM full set na you denoted as a FD of G. Then comma CH. We compare with the FD of G plus comma CH of G equal to N. FD of G plus comma CH of G equal to N. Then strong full FS of G plus comma SE of G equal to N. Comma SE na chromatic strong dominating set. Chromatic strong domination number plus strong full number. Rendu add panningna எப்ப N கிடைக்கும்? We have to characterize Fs of G plus comma SED of G is equal to N. And another one result, FW of G. FW mean weak full of G, chromatic weak full, not weak full. Weak full already exists. Weak full, strong full, DAM full. I think full set. So full set, weak full set, strong full set already defined by Dr. E. Sambat Kumar and Puspalada. That paper is strong weak domination and balance in the graph. Strong weak domination and balance in the graph. So that graph, that paper wrote on 1996, I think. So these results are published in that paper. But we want only DAM full. DAM full mean chromatic, DAM chromatic set, full set. DAM chromatic full set. Chromatic strong DAM full set. Chromatic weak DAM full set. So this is the new definition. This is the new definition. So nobody can find the definition, I think. So this is the pending area of this set, right? FD of G plus comma CH of G equal to N. Fs of G plus comma Sc of G equal to n, Fw of G plus comma Sw of G is equal to n. So this is the bending area. And another one, DOM balanced graph. DOM balanced graph. We can find a DOM balanced graph. So already exists a balanced graph, domination balanced graph, domination balanced graph. I think it is a chromatic, a DOM chromatic balanced graph. We can find a already exist இருக்கிறது என்னன்னா domination balanced graph இருக்கு. A graph G is a domination balanced if there exists an strong dominating set D1 and a weak dominating set D2 such that D1 intersection D2 is equal to empty. D1 intersection D2 is equal to empty. So this is the domination balanced graph wrote by Sambat Kumar, right? So this result is exist. This definition is also exist by but my definition, because Sambat Kumar sir வந்து என்ன பண்ணிருக்காங்கன்னா strong dominating set உருவாக்கி weak dominating set உருவாக்கி அத ரெண்டையும் கம்பேர் பண்ணி we can get a strong full I think strong full, weak full and DOM full இல்லையா full set. அப்போ full set ஃபார்ம் பண்ணிருக்காங்க. After that domination balanced graph போட்டு weak dominating setக்கும் strong dominating setக்கும் intersection பாத்தீங்கன்னா equal to empty இருக்கணும்னு சொல்றாங்க. So அப்ப already we have to discuss a chromatic strong dominating set and chromatic weak dominating set, right? Two parameters. So then we can find a DOM full set, chromatic strong DOM full set, chromatic weak DOM full set, and DOM balanced graph. Chromatic DOM balanced graph. Appo a graph G is a chromatic DOM balanced if there exists an chromatic strong dominating set D1 and a chromatic strong dominating set D2 such that D1 intersection D2 is equal to empty. So this is the new concept of this area. So இந்த மாதிரிலாம் நிறைய having lot of pending research area, lot of pending. If we compare with the two parameters, I think chromatic strong and chromatic weak. So what is the equalities of both? So இதெல்லாம் வந்து நிறைய வந்து உங்களுக்கு வந்து ஃபுல்லா பெண்டிங் ரிசல்ட்டா இருக்குது இல்லையா? So this is the pending area of chromatic strong dominating set and chromatic weak dominating set, right? Okay.
Hello, sir.
Okay. Yes. It's a chromatic connected dominating set. It's a chromatic connected dominating set. So already connected dominating set exist. Connected dominating sets are exist, right? Disconnected dominating sets are exist. Now we can find a new parameter from that set. Whenever you mix it with the coloring and the domination parameter, after that we derive one new parameter. So this is the connected chromatic connected dominating set. A subset D of E is said to be chromatic connected dominating set of G if D is a connected dominating set and chi of induced D equal to chi of G. Chi of induced D equal to chi of G. The minimum cardinality of a chromatic connected dominating set in a graph G, it is called chromatic connected domination number of G and is denoted by comma CC of G. Comma CC of G. So I think myself and my scholar, that concept introduced by myself and my scholar Ms. Angaliswari. Angaliswari or Kalachelvi, I know, right? Okay. So this is the new area. Those are interesting people, you do it, no problem. So because many more results are there. So it is an example of chromatic connected dominating set. It is an example of chromatic connected dominating set. Because that graph of chi is equal to, yes, that graph of chi is equal to C4, so only two. So automatically you take a dominating set. Dominating set mean I think here 5, 6, 7, 8. 5, 6, 7, 8 automatically it is a dominating set. The chi of that graph also 2 and induced chi of induced D equal to chi of G. So therefore, chromatic connector domination number is always 4 of that graph, right? Okay. So now, so chromatic total dominating set. Chromatic total dominating set. A subset D of B is said to be a chromatic total dominating set of G if D is a total dominating set and chi of induced D equal to chi of G. So this is only new parameter. And now my scholar Ms. Angaliswari and myself introduced this concept. Now I think 2 or 3 scholars working that area, right? The minimal cardinality of a chromatic connector dominating set, I think not connected, it is a spelling mistake. Chromatic total dominating set in a graph G, it is called a chromatic total domination number of G and is denoted by comma CHT of G, comma CHT of G. So these are the example of that. I think D is equal to, you take A comma B, because the original graph of chi is equal to always 2. Then you take A comma B because being a point C, D, E எல்லாத்தையுமே dominate பண்ணிரும். B dominate பண்றதுக்கு A இருக்குது, A dominate பண்றதுக்கு B இருக்கு. Then automatically A comma B only the chromatic strong domination, the chromatic total domination number of G. So therefore only we have 2, right? So these are the example of, right? So now we have to discuss a degree divisor graph. That graph introduced by myself and my scholar Dr. Palani Kumar, right? Recently he got a degree, doctorate degree, right? So the degree divisor graph DD of G, of a graph G. So the original graph for you take a graph DD of G is said to be a degree divisor graph DD of G of a graph G with the vertex at V of G and 2 distinct vertices U and V in DD of G are adjacent if and only if degree of U divides degree of V or degree of V divides degree of U. So that is mean you take, I think one example is there. So this is the example. You take one graph. The vertex set of the vertex of 1 degree is 2. 2 the degree is so 3. Here. Okay. The 3 is the degree is 2. The vertex of 4 of degree is 3. The vertex of 5 of degree is 2, right? If 1 in the first point of degree வந்து 2, second point of degree வந்து so 3. So அப்ப என்ன ஆகாது, 2 does not divide 3. அப்ப you could not give any line from 1 and 2. So அப்ப இங்க வந்து இந்த 1 2 இடையில என்ன இருக்காது, லைன் இருக்காது. So after that you see one first vertex and third vertex. The first vertex of degree is 2 and the third vertex of degree is 2. So 2 divided 2. Then after that you give line from அதாவது from 1 to 3. So 1 to 3 இடையில ஒரு லைன் கொடுக்க போறீங்க, ஒரு எட்ஜ் கொடுக்க போறீங்க. So this is the degree divisor graph of G. So I think degree divisor graphல வந்து நிறைய நாங்க ஒர்க் பண்ணல. So ஒரு மினிமம் ஏரியா, அதை அந்த பேப்பர் நீ பப்ளிஷ் ஆகாதனால நான் இப்போ சொல்லலை, ஒரு மினிமம் ஏரியாவில் வந்து நாங்கள் அதை ஒர்க் பண்ணியிருக்கோம். நிறைய அதில் ரிசர்ச் நிறைய இருக்குது. ஸோ அப்போ இன் ஜென்ரலி வி ஹவ் டிஸ்கஸ் டாமினேட்டிங் செட்டை என்னவா மாற்றிருக்கேன், கலரிங்கோட மிக்ஸ் பண்ணி டாம் குரோமேட்டிக் செட்டை மாற்றிருக்காங்க. டாம் குரோமேட்டிக் செட், டாமினேட்டிங் செட் as well as டாம் குரோமேட்டிக் செட், ஸ்ட்ராங் டாமினேட்டிங் செட் as well as chromatic strong dominating set, weak dominating set as well as chromatic weak dominating set, connector dominating set as well as chromatic connector dominating set. Total dominating set is a chromatic total dominating set. Disconnected dominating set, டிஸ்கனெக்டட் டாமினேட்டிங் செட்ல வந்து நம்ம ஏன் அது குரோமாட்டிக் டிஸ்கனெக்டட் டாமினேட்டிங் செட்ல மாத்தல அப்படின்னா டிஸ்கனெக்டட் டாமினேட்டிங் செட்லயே நிறைய ஒர்க் பண்ணல. ஸோ டிஸ்கனெக்டட் டாமினேட்டிங் செட்டை வந்து ஒரு கம்ப்ளீட் பண்ணா தான் நீங்க குரோமாட்டிக் டிஸ்கனெக்டட் டாமினேட்டிங் செட்டுங்கிறத பேச முடியும். அப்ப disconnected dominating set, only one paper are there, only one paper. I think that paper should be contains only 10 theorems. So after that many more results are pending in disconnected dominating set, right? So disconnected dominating set is very nice area. I think it is very nice area. Many more people cited of this paper, but no one can extend that paper. So till now no one can actually no one can extend it, right? Nowadays I saw the net ஒருத்தர் கூட வந்து அந்த இன்னும் அந்த பேப்பர் வந்து எக்ஸ்டெண்ட் பண்ணல. So this paper is very very nice for young research people, and also many more area, many more research area waiting for young researchers, right? So I think I congratulate Dr. M. Anida and his team also, because it is a very nice conference entitled Recent Trends in Pure and Applied Mathematics. It is a very nice area and nice conference. It is initiative, I think. So I congratulate Dr. M. Anida and her team, right? Thank you on and off here.
Thank you, sir.
Thank you.
Thank you, sir. Thank you for your presentation.
I invite Mrs. S. Kalaichavi for giving vote of thanks.
சார் நான் இப்போ ரிசர்ச் ஸ்காலர் சார். நான் இப்போ PhD ஸ்டார்ட் பண்ணிருக்கேன். நான் ஸ்டார்ட் பண்ண ஆரம்பிச்சு நான் எம்எஸ் யூனிவர்சிட்டில பண்ணிட்டு இருக்கேன் சார். எம்எஸ் யூனிவர்சிட்டில சதக் அப்துல் அப்பா காலேஜ்ல படிச்சிட்டு இருக்கேன் சார். ஆக்சுவலி நான் இப்போ நீங்க சொன்ன மாதிரி உங்க பேப்பர்ஸ் எல்லாமே நான் ஒரு பேப்பர் பார்க்க ஆரம்பிச்சது தான் சார். நிறைய பேப்பர்ஸ் ரொம்ப 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 நல்லா இருந்தது. குரோமாட்டிக் ஸ்ட்ராங் டாமினேஷன், அப்புறம் குரோமாட்டிக் வீக் டாமினேஷன், அப்புறம் அதுல ஒவ்வொரு கிராஃப்ஸ் நீங்க சொல்லிருக்கிறது எல்லாமே நான் நல்ல டீடைலா பார்த்தேன். எனக்கு இன்னைக்கு உண்டான இந்த பிரசன்டேஷன் வந்து ரொம்ப 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 யூஸ்ஃபுல்லா இருந்தது சார். சோ தேங்க்யூ சார். சார் ஆனா அதுல வந்து நான் ஃபர்தரா நிறைய கிராஃப்ஸ் சொல்லலாம் அப்படின்னா வேற எதுவும் ஒர்க் பண்ணிருக்காங்களா என்னன்னு எனக்கு அது டீடைலா தெரியல சார். ஏன்னா உங்களுக்கு நிறைய ஸ்டூடெண்ட்ஸ் படிச்சிருக்காங்க. சோ ஃபர்தரா நான் அதை எடுத்து ஸ்டடி பண்ணனும் எனக்கு ரொம்ப ஆசையா இருக்கு. எனக்கு நல்லா பிடிச்சிருந்தது. நீங்க உங்களோட பேப்பர்ஸ் ரொம்ப கிளியரா எனக்கு பார்க்கவும் இன்ட்ரெஸ்டிங்கா இருந்தது. சோ அது நான் ஒவ்வொரு பேப்பரும் எடுத்து பார்த்துட்டு இருந்தேன். குரோமாட்டிக் நெய்பர்ஹுட் அந்த ட்ரீல சொல்லி இருக்கிறது எல்லாமே நான் நல்லா பார்த்தேன். நான் குரோமாட்டிக் தான் பார்த்தேன். குரோமாட்டிக் ஸ்ட்ராங் காம்பினேஷன் அந்த வேலையில உள்ள பேப்பர்ஸ் எல்லாமே தான் பார்த்தேன் சார். அதான் அதுல மத்த யாரும் எதுவும் டீடைலா போட்டுருப்பா என்ன நான் அதை பத்தி உங்ககிட்ட டிஸ்கஸ் பண்ணிக்கலாமா சார்?
அதாவது என்னன்னா நீங்க இது வரைக்கும் இந்த குரோமாட்டிக் ஏரியாவில் ஐ திங்க் 4 or 5 gates are available. So 4 or 5 people this area.
Okay sir.
Myself and Janagaman and சென்னையில ஒருத்தங்க இருக்காங்க. So I think ஒரு 5 or 10 within 10 people are working.
ஓகே சார். இல்ல நிறைய வெரைட்டிஸ் ஆஃப் கிராஃப்ஸ் நமக்கு இருக்குல்ல சார். அதுல தான் எனக்கு வெரைட்டிஸ் ஆஃப் கிராஃப்ஸ் நமக்கு இருக்கு. நிறைய டிஃபரெண்டான கிராஃப்ஸ்லாம் நமக்கு இருக்கு. சோ அதுல வந்து நான் குரோமாட்டிக் அப்ளை பண்ணி அதுக்கு கண்டுபிடிக்கலாமா அப்படிங்கறது என்னோட ஒரு ஐடியாவா இருந்தது. ஆனா அதெல்லாம் டவுட் கேட்டுக்கலாம்னு நானும் ரொம்ப மத்த எந்த எனக்கு ஆப்பர்ச்சுனிட்டியுமே கிடைக்கல சார். நான் திருநெல்வேலியா அதனால தான் கேட்டேன் சார்.
Thank you so much. Thank you
sir. Thank you so much sir.
Ma'am, thank you ma'am.
Thank you ma'am.
I invite Mrs. S. Kalaichavi for giving vote of thanks.
Doing mathematics should always mean finding patterns and crafting beautiful and meaningful explanations. I feel and agree that your beautiful explanations reach to the best understanding. Thank you, sir. Thank you so much for making your talk at most informative and interesting one. Because of our department, I am indebted to thank our keynote speaker, Dr. S. Balamurugan, for his successful completion of session on the topic various and domination parameters. Thank you, sir. Next, I thank our participants for their involvement. We will meet in the next session that will be held on tomorrow at 11:30 a.m. Once again, I thank one and all.